Hello everyone. Today's video is on IXL assignment N5, box plots. Let's get started. The Creekview History Museum kept track of how many people visited the museum each day last month. This box plot shows the results. Please remember in a box plot, a couple pieces of information. Up here, this is called a whisker, and the end of the whisker is your upper extreme. This end of the box, this is your Q3, or sometimes it's referred to as the upper quartile. In the middle is the median. This left side of the box is your Q1, or lower quartile. That's your upper extreme. This is your lower extreme. And each part of this box and whisker is broken into 25%. They take the data set, they break it in half, then they break it in half again, so you have 4 equal parts. Throughout 4 equal parts. The data is distributed through 4 equal parts. So from this whisker to quartile 1 is 25% of the data. From quartile 1 to the median is 25% of the data. From the median to the upper quartile, or Q3, is 25% of your data set. And from your Q3 to your upper extreme is another 25%. Keep this in mind, screenshot it, take notes, pause it right now, so that you know this for the rest of this video. What was the upper quartile? Right here is the upper quartile. This is just an identification problem. Pay attention to your scale. They're counting each tick mark on your line is worth 50. This one's just not numbered. So there's 350 visitors. Mitchell is on his school's track team. He recorded his times in the 100-yard dash at each track meet last year. What was Mitchell's median time? Median, middle of the box. It's right here above 22 on your number line. So his median time in last year's track meets was 22. Another identification problem. Music camp, Addison tracked the number of minutes she practiced her trombone each day. Here's her data set. What was the lower quartile of Addison's practice time? Lower quartile is this piece of the box right here, so it is 70. Gabby is working on reducing traffic in her town. Last week she tracked how many cars drove down Main Street each hour. This box plot shows the results. What percent? Now remember, each part is broken into 25. So this is 25%, this is 25%, this is 25%, and this part is 25%. What percent of the time did Main Street have 100 or more, so greater than 100 cars per hour? Here's my 100. Greater than would be to this direction, because this is, looks like 120, 140. So this would only be this part 25% of the time there's more than 100 cars driving down. Emilio works for the Parks Department of West Palm City. He tracked how many emails the mayor received about the city's parks each day last month. This box plot shows the results. What percent of the time did the mayor receive between 25 and 50 emails? Well, here's 25 right here, 50 out here. So this is the whole box. So remember, this piece is 25, this piece is 25, so 25 and 25. 50% of the time the mayor received between 25 and 50 emails. Okay, now we're going to create a box plot. So the first thing I have to do, the school librarian's keeping tracks of the books checked out, I have to put them in order. I'm going to do that now. Now that I put them in order, I'm going to count how many there are so I can decide where my median is. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points in this data set. So my median is going to be between my 5th and 6th one. So I got 3, 4, 5. This is where my median is going to be between these two numbers. So I got to add these two numbers together and then divide by 2 to decide where my median is. Now I'm going to divide 9,000 by 2, and my median is 4,500. So I look in this first one, the median's not at 4,500. In this one, the median is at 4,500. So this is going, I don't really need to do any more work. I'm just to verify though, Q1 is going to be 3,500 because that's the median of the lower half. Q3 is going to be 5,000 because that's the middle number of the upper half. There's only 5 data points in the upper half, so the middle one is the third one. And if I double check that, Q1's 35, Q3 is 5,000. My lower extreme is my lowest number. My upper extreme is my highest number. So this one checks out because of the median. So we're going to create another box and whisker. First, put the data in order. Okay, now I have the data in order. I'm going to count how many there are. 3, 4, 5, 6, 7, 8, 9, 10. Again, there's 10. So the median is going to be between the 5th and 6th number. Well, right now the 5th and 6th number are the same. So there's really no calculating. If they're the same, the median is going to be 40. Okay, both box and whiskers, the median is 40. Q1 in this data set is 30. Q3 is 60. So let me check them. 30. Oh, this one says 80. This one says 60, 30 for Q1. My lower extreme is 20. My upper extreme is 90. This looks good. This is going to be the correct box and whisker. For his science project, Bill studied frogs that live in a pond near his house. He recorded the weights of the frogs. Again, here's your data set. Let's put them in order. Now that my data is all in order, I'm counting to see how many there are. So that's 3, 5, 6, 7, 8, 9, 10. This time there's 11, so there's an odd amount. So 11, the middle of 11 is 6, the sixth number. 1, 2, 3, 4, 5, 6. I usually just take how many there are, divide by 2. When I have an odd amount, I round up. So I round 5.5 up to 6. That's how I calculate my median number. 3, 4, 5, 6. So the median is 22. Well, that has a median of 22, so does this box and whisker. Now, in my lower half, I still have 5 numbers. So the middle number down here is going to be Q1. So that is 20. Remember, this is the median. I didn't mark that. And then up here, Q3 is going to be 24 because that's the middle number of the upper half. So 20, yes. 24, that looks good. Nope, this one has Q1 at 19, so this is no good. This is the graph we want to go with. Bella works at a popular clothing store. Last winter, her manager asked her to track the store's sweater sales. This box plot shows the results. Okay, what fraction of the sweaters? Now remember, 25% is a fraction 1/4, right? If we convert 25%, it's 25 over 100, and it reduces to 1/4. So we could also use the fraction 1/4 to represent how this is broken, because it's broken into quarters. 50 or less, here's 50 or less. So that's 2 quarters. 2 quarters is 50%. 50% is 1/2. A quarter plus a quarter is 2 over 4. 2 over 4 is 1/2. Thanks for watching. Hope this video helps you achieve your goals in your IXL assignment.